Hello guys, welcome to Start Pro Tutorials. In this session, we'll be discussing about a bridge truss as shown in the figure. So you can see this is the truss of 50 meters length with 8 bays totally and 4 by 4 meter width by height. So let us begin the session. Initially start Staad Pro, select new project, select truss, units are meter and kilonewton, select name, select next, finish. Then you can go to geometry, select structural wizard, select halfway bridge. As you can see, bridge can be of Pratt truss and halfway bridge, but here we have halfway bridge, since you can see here like this, whereas in Pratt truss it begins downwards, here it begins upwards, the node point is upwards. See here, so double click it, length is 50 meters, number of base is 8 and height is 4 meters, width is 4 meters. Now select OK, apply. So you can view, actually this is something different. So we'll just draw it once again. Length 50 meters, number of bays will be 8, height is 4 meters and width is 4 meters. Select apply. So you can see in this way we need more 2 bays. Actually we have this 3, but coming to figure we have total of 8. It means the number of bays are 16 and 18. Select 18, then select apply. Now you can see this is your truss bridge. You will just transfer it to main Start Pro screen. Switch off the grid. So you can see this is our bridge truss as shown in the figure. However, there is a beam exactly at 1 meters from both sides along widthwise. So we'll select now. We need to create a node point. Okay, in this way nodes are created. Let us see from top. You can see this is the top view. However, so we can using add beam, we can add in this way. This is just adding of the points since we have not specified the properties as beam as well as angles. So you can see beams are created. Well, now that you are done with the bridge truss, you first go to general. You will select section database, and we have all these steel materials. So in the before sections, in trusses, all the American steel materials were assigned. So we'll close this one, go to define, select assign profile, we'll select angle, double angle, then coming to channels. So first angles, going to front view, we'll assign to these members. Now assign to those selected beams, then assign double angles to all the top members as well as the vertical members. Now assign channel to all the bottom members. Now we are done with the property modeling. Since the still we are not applied, so we go to support next, create support, which will be fixed support. Select front view, select the end nodes, assign to the selected nodes. Actually you need to assign to these two ends. Actually need to assign these four ends, just the ends of the bridge truss. You can see now assign. Then coming to loads, select load case details. Before that, since bridge truss do resist earthquake, so we will define seismic activity. Select add, select the yes code, select generate. Give the parameters, select generate, then select add. Now you go to load case details, select dead load, loading type will be dead, and live load, loading type will be live, and earthquake load in x positive direction, earthquake load in x negative direction. Okay, that would be enough. Now go to dead load, select sulfate, add. Coming to member load, select minus 12 kilonewtons per meter, and floor load will be minus 4 kilonewton per meter square within the range of 0 to 2 meters, actually on the base floor. Then going to live load, selecting floor load, which is minus 2 for 0 to 2 meters, for both 0 to 4 meters. On the roof also minus 2 kilonewton per meter square. Then going to earthquake load, selecting seismic loads, x direction positive, select minus 1 in order to specify negative direction, assigning it to the entire structure. Then going for uniform redistributed load, minus 12 kilonewton per meter will be acting on the bottom channels. Then we'll define few load combinations, which will be dead load plus live load plus earthquake load x positive, with 1.5 factor of safety. Then coming to dead load plus live load plus earthquake load in X negative with same factor of safety. Two load combinations will be enough. Once we are done with load combinations, we can go to design, select parameters. You can define one parameter. Before that you need to select IS code 800 and then define parameter FYLD, yield strength of steel, which will be 415000, or you can even keep 500,000 kilonewton per meter square. It will be Fe 500 steel. Then giving commands check code and take off. Then analyzing the structure. So there the error exists. Let us see it. 1893 or deferred before any other load cases. Okay. So here we need to, in load cases and definitions, we need to define earthquake loads before dead load and live load. So we'll do one thing, we'll remove this, we'll delete the loads, earthquake loads, and also in definitions in order to simplify, and we'll edit this. Now we'll analyze. Warnings about instability will be provided if present, but before that we'll check for any failed beams. So you can see those are the failed beams. What we'll do is we'll see what type of beams are provided. You can see channel is 10 by 20 and this is American. So what we'll do is we'll just delete this American. We'll select assign channel, select section database, then go to Indian, select channel, select the channel as per your specifications, ISMC 200, select channel double back to back, select assign, then going to assign double angle, section database, go to Indian codes, select angle, select as per your specifications, long leg back to back double angle, 4530 by 3 or else 4530 by 6, assign, then select assign angle, section database, go to Indian, select angles, assign 40 by 6. So now that you have assigned your angles as specified by you, you analyze the structure. So these are the failed beams. This would be a trial and error process in order to have different profiles. So what we'll do is we'll go to design tab, select commands, select, add, then select take off, close. Now assign select to the all beams, then steel take off to all beams. Select command will automatically select the angles, channel, double angles precisely so that there will be no failure. Now you can go to geometry, sorry, you can go to select by specifications all failed beams. So you can see these are the angles which have failed. So we go to front view, let those angles be selected, go to property, we select assign double angle. Let us see once again which beams have failed. So these are failed. So what we'll do is select assign double angle, and we'll assign double angle to these angles. Then we'll go to top view. So we'll assign beams for these three. Before that we need to define beam. So we go to assign profile, select beam, and now assign the beam. Just to the end three failed ones. Now once again you can analyze and see if there are still any failed beams occurring. so there are no beams filled. So like this we can improvise by adding beams, say like channels, different channels, whatever you require. You can see now that we are provided with all the Indian angles and channels. You can see the deflection occurring downwards. Coming to reactions, instability is obtained at few joints, then going to beam stresses. You can select a beam and obtain the stresses for that. In unity check, you can see pass or fail. Failed members, there are no failed members. So graphs can also be obtained. Animation for section displacement. You can see reports are also obtained later on for whatever we require. So on going to analysis and print, we directly select analysis, no print add. But however, after doing this, we can go to post print, define few commands, and if we for this load list and physical maximum forces, all the buckling shapes, whatever parameters which we require in this bridge trusses to obtain in Staad output can be obtained from here by giving the commands. So this is the end of the bridge truss session. In the next session we'll be discussing about the industrial truss as shown in the figure. Thank you. Subscribe for more videos.